Hi everyone, today we have discussed about trees in data structures. What is a tree? A tree can be defined as a finite set of data items, that means a nodes. Tree is a non-linear data type of data structure in which data items are arranged or stored in a sorted order. Tree represent in a hierarchical representation between various elements. There is a special data item at the top of the hierarchy called the root of the tree. The remaining data items are partitioned into number of mutually exclusive subsets, each of which itself a tree in which is called a subtree. A tree always grows in length towards the bottom in a data structure, unlike natural trees which grows upwards. A tree structure can be organized into two branches which are related to the information. You are all know about the trees, that is in a hierarchical representation. First node is called as a root node and the other nodes are called the childs. First we have discussed about the root. What in general we are know about trees, it grows up only, it does not grows down. But in data structures the trees can be grows down only, not upwards. Tree data structure is a collection of data, that means a node, which is organized in a hierarchical structure. In tree data structure, every individual element is called a node. That means we have, for example, if you take the tree, in that example we have discussed about the 11 nodes and 10 edges. The 11 nodes are A, B, C, D. In that way we have take n edges, then n edges are called the n nodes are called the tree's data structure. In any tree with n nodes, there will be a maximum of n minus 1 edges. In a tree, every data structure, every individual element is called a node. In every element is called a node and every element between the edges is called a edges between the two nodes. The first node is called as a root node. Every tree must have root node. There must be only one root node. We never have multiple root nodes in a tree. That means if you have a first node as a root node, then the other nodes are called as a childs, not as a root node. They are also called as a childs. Edges. The connecting link between any two nodes is called as an edge. Between A and B, we are connecting an edge. That means A and B has a link in between them. That link is called as an edge. In a tree with n number of nodes, there will be a maximum of n minus 1 number of edges. That means if you have 5 nodes, then we have 4 edges in every link. That means if you have a 1, 2, 3, 4, 5, then for every node, for each node, between two nodes we have a link between the edges. We have a link. That link is called as an edge. Parent. A parent node is called as a predecessor of any node is called as a parent node. That means in simple words we have to tell that the node which has branched from it to any other node is called as a parent node. We are also defined as the node which has childs. That means if you have a children for any node, that node is called as a parent node. For example, in the given, A is called as a parent node for B and C, and D and E or childs for B. That means B is a parent node for D, E and F, and C is a parent node for G and H, and E is a parent node for I and J. That means for every node we have some child nodes. For each node we have a child nodes. That node is called as a parent node. Child node. The node which has a link from its parent node is called a child node. In a tree, any parent node can have any number of child nodes. In a tree, all the nodes except the root node are called as a child nodes. Because the node has in a tree we have only one root node, that is first node is as a root node. All other nodes are called as a children. Because the root node has a child, that node has a child. So there is a descendant of any node as a child node. First node is also called as a root node. So for in this given example, B and C are children for A, and D, E, F are children for B. G and H are children for C. I and J are children for E. K is children for G. Like this we have. For first node is called as a root node, and next all of the nodes are called as a children nodes. Siblings. In a tree data structure, nodes which belongs to the same parent are called as siblings. In simple words, we know the nodes with same parent are called as a sibling nodes. In the given example, B and C are siblings, but B and C are siblings. D, E, F are siblings. G and H are also siblings. I and J are siblings. K is the only one child. As we discussed above, the root node is the first node is called as a root node, and the links between the two nodes are called as an edge, and the parent node, first node is called as a parent node. If any node has childs, that node is called as a parent node. Child. Then all the nodes except the root node is called as a child node. And the siblings. The node which belongs to the same parent are called as a siblings. Next we discussed about leaf nodes. What are called the leaf nodes? The nodes which does not have a child is called a leaf node. The leaf nodes can also be called as external nodes and terminal nodes. External nodes is also a node with no child. That means in a given example, we looked on it D, I, J, F, K and H. They have no child, so they are called as a leaf nodes or terminal nodes or external nodes. And next we are discussed about internal nodes. In a tree data structure, the node which has at least one child is called as an internal node. That means must and should have only one child, at least one child. Then we are called as an internal node. In a tree data structure, nodes other than the leaf nodes. What is meant by leaf node? The leaf node does not have any child. That means we don't have any children. But in internal nodes, at least we have one child. So they are called as internal nodes. The root node is also said to be an internal node if the tree has more than one node. Internal nodes are also called as non-terminal nodes. Remember one thing, leaf nodes are called as external nodes or terminal nodes, and internal nodes are also called as non-terminal nodes. Degree of a node. How to calculate a degree for a node? The degree of a node is the total number of children it has. For example, in the given example, degree of A means the total number of children what it has. That means there is a 2 children for A, B and C. So the degree of A is 2. Like that, for every node, if you calculate the degree, the number of children if you have that is the degree of that node. The highest degree of a node among all the nodes in a tree is called the degree of tree. That means in a given tree, the degree of a tree means then the highest number of children if you have that. That means in this given example, the node B has 3 childs. In a given example, this is the most highest number of children it has. So the degree of a tree means that it is a 3. If you are asked for a degree of A means it is 2. If you are asked the degree of a tree means it is the highest number of children for a tree. So it is 3. Next we have discussed about the level of a tree. What is the level of a tree? The root node is said to be at the level 0 and the children of the root node are at the level 1. And the children of that nodes which are at level 1 will be goes to the level 2, and that we have to go on. In simple words, in a tree, each step from top to bottom is called as a level. The level count starts with 0 and incremented by 1 at each level. That means in a given example, the root node A has a level 0 and B and C has a level 1, D, E, F, G, H are at level 2, I, J, K are at level 3. If you are asked the level of a tree means the level of a tree is given as a 3. If you are asked the level for H means the level of H is at 2. Like that we have discussed about the level. Next we are discussing about height and depth of a tree. What is the height of a tree? If you are discussed about the height for a given number, that means the depth of the height of a node is the number of edges present in the longest path connecting to that node to a leaf node. That means if you are asking the node for a single node, the height of the tree means that level to till the leaf node, we are discussing about the number of edges. The number of edges counting is becomes to the height of the node. That means the node present at the level to leaf node. For example, if you are discussing about the height of a node for 10, then the height of a node for 10 is 10 to 25 is the one edge and 25 to 45 is the another edge. So the height of a node is 2. If you are discussing about the depth of a node, the number of edges present in path from root node to the tree to that node. That means from the root node to that node, how many edges are there, we have to count and we have to reply that as a depth of a tree. For example, for the depth of a tree, depth of a 10 in a tree is 5 to 10. The 5 is a root node, so 5 to 10 is one edge. So the depth of a node for 10 is 1 and the height of a node for 10 is 2. Like that we have to calculate the height and depth of a tree. What is meant by a subtree? In a tree data structure, each child from a node forms a subtree recursively. That means the root node is only one node and each child from the other nodes is called as a subtree. Every child node will form a subtree on its parent node. Like that we have an example for there is an tree A, B, C and we will have another tree D, E, F. So B2 we have a one tree and another one C2 we have another subtree. So for each child from a node forms a subtree recursively. We have to form some trees recursively. What is meant by full binary tree? A binary tree is a full binary tree if it contains maximum possible number of nodes in all levels. That means we have to complete all the levels of a tree with a maximum number of nodes. That means we have first one node with the two childs and the another node with the two childs, not as 0 and 1. Completely two child we have to given. Complete binary tree. What is meant by complete binary tree? It is said to be a complete binary tree if all its levels except possibly the last is completely filled and all the nodes as far as left as possible. That means we have to complete the binary tree. We have to tell that binary tree is complete binary tree. That means all the nodes except the last one. If it is possible, then it is also a completed. If it is not possible, the last one is not completed and the other nodes must be completed with two nodes. Then it is called as a complete binary tree. And the next one is strictly binary tree. What is meant by a strictly binary tree? A binary tree in which every node has either 2 or 0 number of children. That means every node must be a 0 or 2. The node which does not have a single child and the node does not have a 3 or 4 and another childs must have 0 or 2 childs. Strictly binary tree is also called as a full binary tree or proper binary tree or two tree. We have also tell that it is a full binary tree and two trees. Strictly binary tree data structure is used to represent the mathematical representations. In a given example, we see that it operates an example for A plus B and star C. That means it operates and mathematical operations can be occurred in strictly binary tree. Next, we are discussed about recursive implementation of traversing binary trees. That means tree traverses is very important for in our data structures. It refers to the process of visiting each node in a data structure exactly once. That means we have to visit every node at least one time. There are three algorithms called pre-order, in-order and post-order. Pre-order means first we have to visit the root and next we have to traverse the left subtree and next we have to traverse the right subtree. That means it is a pre-order. So first we have to traverse root child and then left child and then right child. There is an example. First look at it on A, B, C, D, E, F, G. There is an example like this. If you have to traverse that in a pre-order, first we have to visit the root node. What is the root node? There is a root node as A. And next we have to visit left child. So there is a left child as B. And then there is a right child and there is another left child that is B, D. And next we have to go on right child. That is a right child as E. and then we have to right child of A is C, and then F and G. It is a traversing of pre-order. And next we have to discuss about in-order traversal. In this we have to traverse the left subtree, and then we have to visit root node, and then we have to visit the right subtree. That means the order is left subtree and then right and then root. Just look it on the example. In-order traversal is used to get infix expression of an expression of a tree. That means we have to visit postfix expressions to infix or infix expressions to postfix. There is an evaluations. That in that we have to discuss about these expressions. Infix expression is very much important than another examples. Next one we have to discuss about post-order traversal. We have to travel in this. We have to first traverse the left subtree and then right subtree, and then we have to visit the root node. There is an example. Just look it on. First we have to visit the root node. First we have to visit the left subtree, that is D, and then right subtree E, and then root node is B. And next in the right subtree there is a left subtree F and right subtree G, and then root node is C. In above the root node is C. Like that we have to traverse the tree. First we have to traverse the left subtree and then right subtree and then root node.